Okay, hello everyone. I welcomes to all in our lecture series on conversion of numbers from one system to another. In this lecture series, we are going to discuss these topics. These topics are very much essential for BSc, BTech, MSc, MTech and various entrance examinations like CUET, CPT, JAM, GATE, NET, TF and etc. So let us start our first topic, decimal to binary and binary to decimal conversion. Okay. So before we are going to start our first topic, we have to just recall whatever we have been studied in our childhood. Suppose we are going to consider decimal number 34. Here that 34 divided by 3. Okay. And we can found 11 is your quotient. Here 34 is called as your dividend, 3 is your divisor and the remainder we can get 1. Now if the 34 is going to divided by 2, we can get the remainder 0 and your quotient is your 17. Okay, you just remember this is called as your quotient and this is your remainder. This is your divisor and this is your divided. Okay, okay. Now our work start. First lecture work, that is decimal to binary conversion. Here I am going to explain step by step. Carefully you just watch. Consider the decimal number 34. To convert decimal to binary, we have to divide this number, a decimal number, by 2. So first it is divided by 2. Here 2 is your divisor and 34 is your divided. If I am going to divide these two, we can get 17 as quotient and the remainder will be 0. Again we are going to divide the 17 with 2, we can get quotient 8 and the remainder will be 1. Again divide by 2, we can get quotient equal to 4 and remainder will be 0. Again divided by 2, we can get quotient 2 and remainder 0. Then again divided by 2, we can get quotient 1 and remainder 0. Until the quotient will be 1, we have to divide 2 each time by this procedure. Then we are going to consider from bottom to top, that means from this number to this number. So each time we got either 0 or 1, 0 or 1 remainders. Finally we have to consider these 1 0 numbers from bottom to top, like this. Here from 1 0 0 0 1 0, how we have to write? Like this, 1 0 0 0 1 0. So here 34 is the decimal number, corresponding binary number is this one. Here why it is called the binary? Because either 1 or 0. So now this is the representation of, this is the binary representation of decimal number 34. Now we have to just verify that is it so. Here binary to decimal conversion, we consider the same binary number, this one 1 0 0 0 1 0 binary number. How we are going to convert this binary to decimal? This is the procedure. See, this is the right end number, this is the left end number, or this is called the LSB and this is your MSB. So here LSB means least significant bit, this is the most significant bit. MSB means most significant bit. So the procedure to convert binary to decimal, what we have to do? First we have to consider least significant bit and multiplied with 2 to the power 0. So this is your LSB, least significant bit, into 2 to the power 0. Why 0? This number is 0. So as it is your least significant bit, so this is written as 2 to the power 0. Now we are going to consider second one, second least significant bit, that means this one. So here how we have to write? 1 the number into 2 to the power 1. Then we are going to consider third one, this one, 0 into 2 to the power 2, fourth one, 0 into 2 to the power 3, fifth one, 0 into 2 to the power 4, sixth one, 1 into 2 to the power 5. In this way we are going to consider. Then we are going to add these values like this value plus this value and so on. You just add it and you can find the value will be 34. So here the binary number this much converted to decimal, and it is found that 34. So here we have been verified that this number, this binary number, is the binary number of the decimal number 34. Okay. Now similarly you can consider any number, any decimal number, and follow this procedure. Now we are going to go for to find out the binary number of a fractional decimal. Here we consider a fractional decimal number is your 34.25. Here 34 is your integer part, 0.25 is your fractional part. How this number is going to be converted from fractional decimal to binary conversion, that we are going to discuss step by step. This is the procedure. With procedure we are going to discuss step by step. Here before that, here I have to write first the binary number of this decimal 34, just before we have been discussed in our previous slide, is equal to 1000010. This much we already evaluated. Now we have to just find out what will be the binary number of this 0.25 by considering this procedure. Okay, here is the procedure tells that the fractional part will be multiplied by 2 each time until integer part will come as 1 and fractional part will come as 0, where integer part taken as answer. Then if 1 not came after 5 to 6 times iteration or multiplication, then we have to take an optimum iteration or multiplication or approximation. So what are the steps? Here I have been written that we are going to discuss by considering this fractional part 0.25. So first we have to consider 0.25. Here it is written that the fractional part will be multiplied by 2. I am going to multiply with 2. Then after we found 0.5. So here 0.5. In this 0.5 number, 0 is your integer part, 5 is your fractional part. So this 0.5 or 0.5 can be written as 0 plus 0.5. Here multiplied by 2 each time until integer part will become as 1 and fractional part will become as 0. So here you can see we found integer part 0 and fractional part 0.5. That means yet we not got the answer. And then where integer part taken as answer, here integer part is 0. So for this multiplication or for this step we have to consider the answer is your 0. So we have to take separately 0 over here. This 0 has taken as the answer for this multiplication. Now we are going to consider this fractional part 0.5, and again we are going to multiply it with 2. The result will be how much? 1, or we can write 1.0. So here 1 is the integer part and 0 is the fractional part, or we can write 1 plus 0. So the integer part I told that is our answer. So integer part taken separately and written over here. And here what we found? We found integer part is your 1 and fractional part is 0. So what is written in the procedure here? You can see until integer part will come as 1 and fractional part will 0. So here we got the same. That means here we have to stop our iteration or approximation. Now what will the answer? Answer means the binary number of this fractional decimal number will be this one. That means we have to consider from top to bottom, 0, 1. So for 34 already we have been evaluated, this much is the binary number. 0.25 binary number will be 0, 1. So finally the answer will be 0.1, or we can write the answer will be, or the decimal number, this one 34.25 decimal number will be equal to this much. For 34, this one 1000010, and for 0.25, this is your 0.1. After point, it will be written as like this: 0.1. Binary number is represented by subscript 2. Right. Now we have to verify this binary number is represents the decimal number this much or not. Here, this side, the heading I have been written fraction binary number to decimal conversion. Here, fraction binary number is your this much. Decimal number of this binary number is your 34. Already we have been evaluated. Now we are going to consider 0.0011. What will be its decimal number? Here, for this case, for fractional case, we have to move from this side, but for the integer case, we have to move from this side. Okay, may you remember I have been explaining the first slide. Okay, so here we have to consider the first bit or first number 0 multiplied with 2 to the power minus 1. Second number 0 multiplied with 2 to the power minus 2. Third number 1 multiplied with 2 to the power minus 3. Fourth number 1 2 to the power multiplied with 2 to the power minus 4. This is the procedure that we have to convert from fractional binary to decimal, corresponding decimal. So we have to just add these values, this value here, this value here, this value, and this value. This value is your 0, and here 0. This value is 0. This one 1 by 2 to the power 3, 1 by 2 to the power 4, or this is your 1 by 8 plus 1 by 16. If I will be calculate, 1 by 8 is your 0.125. This one 1 by 16 will be 0.0625. So finally we got 0.1875. It can be approximately equal to 0.19, but not is equal to 0.23. It is very far from this value 0.23. That means what we approximated the 0.23 value to its corresponding binary number, it is not, it is this value is not approximated exactly, or not, this value is not nearby 0.23. That means we have to again multiply with 2, or we have to again do the approximation or iteration. Here I written the word iteration, means again multiplication by 2, or again we have to consider the approximation. Here we multiplied the 4 steps, 1 2 3 4. Okay, now we are going to go for here. So this value is not matched with not nearby itself 0.23, so we have to need more iteration. Means up to this much we done. Now we are going to multiply 0.68 into 2. The integer part 1 taken separately, and fractional part we get 0.36. Again 0.36 multiplied with 2. Here we got integer part is your 0 taken separately, and fractional part is your 0.72. So here we done extra iteration, extra 2-step iteration, and we found the value is your top to bottom. We have to consider 0 0 1 1 1 0. I have been written over here 0 0 1 1 1 0. So the answer will be for 34 this much, and for 0.23 we got this one 0 0 1 1 1 0. Okay, now we have to verify this much value, this much fractional binary value. If we are going to convert it to the decimal, then how much we can get? Here you can see, here we just verified. Already we know this much value corresponding decimal is your 34. Now we have to find out what will be the decimal number of this fractional binary number. Here 0 0 0 2 to the minus 1, 2 to the minus 2, 1 into 2 to the minus 2, 1 into 2 to the minus 1. Already we have been discussed. Now extra 1 into 2 into 2 to the minus 5, 0 into 2 to the minus 6. Now you just add it, we can get the answer is equal to 0.21875. That means we can say it is approximated to 2.22, right? 0.22, but we need 0.23, right? So it is not came as 0.23 value. Here if I am going to take this much value, 0.1875 as 2, so it will be maximum 0.22. So 0.23 we need, so we need more iteration. More iteration means up to this much we done, again 2 steps we have to go. 0.72 multiplied with 2, we got 1. 0.441 is taken as the answer. Then 0.44 multiplied with 2 and we get 0.88. 0 is the integer part taken outside or taken separately, and this is the fractional part. Now we have to consider the answer. The answer will be this one: 0 0 1 1 1 0, another 1 0 added over here. So final answer in this way we can write. For the 34 corresponding binary number is this one, and for 0.223 the binary number is this much. Now we have to verify this one. Okay, here we consider, see, 0 0 triple 1 0 1 0, 0 0 triple 1 0 1 0. So same procedure up to this much: 0.2 into 2 to the power minus 6, then 1 into 2 to the power minus 7, then 0 into 2 to the power minus 8. We have to just add these values. See, this value 0 0, this value will be 0, this value also 0. And again, if we are going to go for the simplification, finally we found this value 0.22656, or approximately we can write 0.23. Now this is, we can say, optimum iteration or optimum approximation. So here we have to stop the iteration and the final answer will be this much. For 34 binary number is this one. For 0.23 the binary number will be this much. Okay. So this is the procedure that you have to find out the fractional decimal to binary conversion. Okay, here I am going to share one important thing for you. Suppose this question asked in your BSc or BSc examination for 3 to 4 mark. 3 to 4 mark, that means you have to do these steps. That means optimum iteration you have to do. Up to this much you have to do. But in entrance examinations, options are there: A, B, C, D, choices will be there. This question asked, you have to find out the corresponding binary. 4 choices are there. At that time you have to carefully watch which option given in the answer. Maybe, see, maybe this answer will be there, or maybe previous two answers. The previous two answers, maybe in any one of the option this 6 iteration answer will be there, maybe this 4 iteration answer will be there. See, in entrance examination, how much iteration they have been considered for the answer, that they know. So you have to careful about that at the time of entrance examination or option questions. This answer will be acceptable, this answer also will be acceptable, and this answer also will be acceptable, but carefully you have to watch which answer has been given. Maybe this answer not given, this answer suppose given after 6 iteration answer given, so this answer will be the answer. You have to click on that particular option. Suppose this after 4 iteration answer given, so this also will be the answer. Carefully at that time you have to handle this type of question. Okay, in this video we have been discussed in detail how to convert decimal to binary, fractional decimal to binary, and vice versa. In our next class we are going to discuss decimal to octal conversion and vice versa. Okay, thank you so much for watching this video. Thank you.